I decided I want to do one more. I get to do those things. This is one that's, I think, common enough in some of your other classes that I think it's worth looking at it. So let's do one more equivalent resistance problem before we look at sources and things of that sort. So if you're looking at this, and I know that some of you have taken your modeling and instrumentation already, probably more likely in instrumentation with this one, you might go, oh, it's a Wheatstone bridge. And it is, and that's okay. It's a circuit. Everything I teach you can be applied to circuits no matter where you go. Different people use different language and ways of approaching problems, but that doesn't change the underlying physics or the underlying analysis methods. So if you see problems like this, you can think of it as an equivalent resistance problem. Later on, we'll look at it, we'll revisit it, and we'll look at it using some of our analysis methods, mesh and nodal. My UPS just tripped. There's a thunderstorm outside. You're still here, though, so we're going to keep going and hope this works out. Okay. Anyhow, so let's get this down into one to one resistor, same as we've been doing. Okay, find RAB. Now we play the same game. What's in series? What's in parallel? Now here's the trick. 3K and 2K. Somebody's going to raise their hand invariably and say the 3K is in series with the 2K. They share a node exclusively. Well, yes, as it's drawn here, but no, because we're going to connect something to A. We're going to connect a strain gauge or a voltage supply, or there's any number of pieces of equipment that we could connect there. Because of that, 3 and 2 don't share this exclusively. This is a terminal to be connected to something else. Okay, but there are things that are in series and there are things that are in parallel. But a lot of people fall into the trap that thinking these are in series, and similarly that these are in series, and that's not the case. What we end up with is that these two are in series. They share this node exclusively, right? Shared exclusively. And hopefully if I've given you that much, you also figured out that so is that one, right? So we get 3K plus 5K equals 8K. Okay, now if you're plugging that in your calculator or MATLAB or whatever you're using to do these calculations, I hope you're doing these calculations along at home. It would be 3E3 plus 5E3 equals, and what's going to come out of your calculator is 8E3. Okay, if you make it part of the number, you don't have to think about it. Who wants to think less? I totally do. Okay, so that's that one. Down here, these are in series, so we get 2K plus 6K. This one also equals 8K, almost like I planned it that way. It's been a while since I made this problem. But it certainly makes the next piece easy because they're both branches between A and B are 8K. So let's redraw that, right? We remove all of the circuit that we just combined. So we ended up with the 3K and the 5K connected up here. Both go between A and B. We lost the node between them. And this is 8K. Okay, and down here between A and B we have the 2K and the 6K. And that ends up being 8K as well. What's in series and what's in parallel? Well, look at the nodes. The nodes again, there's only two of them, and both of the 8Ks are connected to them. They're connected to A and they're connected to B, so they're in parallel. Okay, and we have an 8K in parallel with an 8K, so two branches, they have the same resistance, they're in parallel. We can just cut it in half. So 8K in parallel with 8K is 4K. Okay, 4 kilo ohms. And there's your answer. All right, so yeah, if you've done this stuff in other classes, if you haven't done this stuff in other classes, you can always go back and apply it to any electric circuit. That's my goal. I want you to be able to analyze any electric circuit when you come out of this class. Semiconductors are another thing, so we'll leave it to linear components, but any electric circuit. That's what I want you to analyze. Okay, so I want you to see an example. This one's slightly more practical in that it's a bridge circuit. It's often used in instrumentation of devices. Okay, now on to series and parallel voltage and current sources and when we can combine them and how we do that. All right, so stay tuned and good luck, folks.